recent months here on the Thunderbolts YouTube channel, I was privileged to help present the final treatise of our friend and the leading proponent and pioneer of the electric universe, Wal Thornhill. Wal's epic analysis of images from the James Webb Space Telescope illuminated the state of crisis that Big Bang cosmology faces, in light of increasingly detailed and accurate scientific data. I'll note that Wall's prediction that cosmologists will look to simply add more epicycles to the Big Bang story has already received some confirmation. One such example: in response to the completely unexpected maturity of the so-called earliest galaxies, which in Big Bang theory should be the least evolved, a paper has just been published in the monthly notices of the Royal Astronomical Society proposing that the Big Bang happened 26.7 billion years ago. In other words, it effectively doubles the hypothesized age of the universe. While some science journalists have characterized this paper and its theoretical underpinnings as, quote, fringe or quirky, we are still left to wonder when we might see institutionalized science be willing to entertain a universe of unknown age and extent, much less entertain the predictive, logically sound, and experimentally verified principles of plasma cosmology and the electric universe. One of Wall's greatest contributions was his original work into the electrical nature of the birth, life, and death of a star. In 2007, Wall's paper on the supernova 1987A was peer-reviewed and published in the IEEE Transactions on Plasma Science, the world's leading publication on plasma physics. Wall rejected the standard view that stars form in isolation due to gravitational collapse in molecular clouds, and he instead embraced the plasma cosmology view that stars form along, quote, cosmic transmission lines at the focus of the plasma Z-pinch effect. However, Wall differed from plasma cosmologists in that he proposed that stars are powered by external Birkeland currents rather than an internal thermonuclear engine. Although I left my full-time duties as creator of Space News from the Electric Universe in 2020, I've continued to read space science news headlines on a regular basis. In recent weeks, I noticed items that seem significant to the fundamental question of what a star actually is. The first headline is entitled, "Record-Breaking Planet-like Object Found That's Hotter Than the Sun." The Science Alert article states, "An object orbiting a star 1,400 light-years away is seriously confronting our notions of what's possible in the universe. It's a brown dwarf, the curious category of objects that straddle the gap between planets and stars. But it's on such a close orbit with its very hot host star that its temperature exceeds a blistering 8,000 Kelvin. That's far hotter than the surface temperature of the Sun, where temperatures sit at a comparatively balmy 5,778 Kelvin. In fact, this brown dwarf is a temperature record breaker, the hottest object of its kind we've ever found. Even though brown dwarfs tend to be hotter than planets, they burn cooler than the coolest red dwarf stars. They absolutely cannot reach Sun-like temperatures on their own internal fusion engines." Now, it must be noted that it was rarely, if ever, surprising to Wall when a star of any kind, quote, challenged the notions of what's possible in the universe. On the description of any dwarf star as a, quote, failed star, Wall wrote, "In an electric universe, there is no such thing as a failed star. They have no thermonuclear engine to fail. All bodies in the galaxy receive external electrical energy from the galactic circuit. Radio astronomers, for the most part unwittingly, trace the circuit by mapping the magnetic fields of galaxies and stars, which fields are generated by the electric current flowing in the circuit. The circuits are unrecognized due to the mistaken conviction that magnetic fields can be, quote, frozen into plasma. The father of plasma physics, Hannes Alfvén, appealed against this mistaken notion in his Nobel Prize acceptance speech in 1970. But to give up this false belief would require discarding decades of theoretical work and reputations built upon it. Wall published the words I've just quoted in a 2008 piece on his website entitled NASA's Dim View of Stars. Wall outlined the electric universe explanation and predictions specifically for various types of dwarf stars. I first consulted this piece weeks ago after I encountered the space science headline entitled Dead star's magnetic field tricked astronomers into thinking it was heading our way. The story describes how a team of Russian scientists using data from the Gaia mission concluded that a white dwarf star was going to pass within 0.49 light-years of the Sun in 29,000 years. Of course, that would bring the star perilously close to the solar system's boundary, producing chaotic effects. However, other teams of astronomers have analyzed the same Gaia data and come to very different conclusions. One such team, led by UK astronomer John Landstreet, concluded that the star's magnetic field produced, quote, an illusion of motion. As described in the ScienceAlert.com article, a powerful magnetic field could distort the spectrum of a white dwarf, so the team obtained new spectra and performed new analyses to derive its magnetic field. They found that the hydrogen alpha line was strongly shifted towards the bluer part of the spectrum by the white dwarf's powerful magnetic field. This could make the star appear as though it is moving towards us, since its movement can make light wavelengths appear to compress and shorten towards the blue range, a phenomenon known as blue shifting. In this case, Landstreet and his colleagues found the blue shift results in an illusion of motion. The velocity of the star, they found, is closer to around 83 kilometers per second. That means it isn't a hypervelocity or runaway star, and it's not going to run into the Oort cloud in 29,000 years, or indeed at all. While this item may not convey any blockbuster scientific revelations, I think it's useful in at least illustrating some of the challenges astronomers face in trying to determine such seemingly straightforward facts as the motion and velocity of certain objects even in the local vicinity of our Milky Way galaxy. And if astronomers have been fundamentally astray for generations on the question of the primary organizational force in the universe, as we shall hear Wall argue in a moment, then of course, astronomers' ideas and interpretations on a whole host of observable data, including the age, size, density, and evolutionary life of an object such as a star, will lead to intractable problems, or a crisis in theory. For our purposes here, I'd like to now read to you the portion of Wall's 2008 entry entitled Success for the Electrical Model of White Dwarf Stars. I think you'll see that his comments are every bit as relevant now as they were 15 years ago, and I encourage viewers to read the full HoloScience.com article for themselves. Wall begins with a comparison of the Hertzsprung-Russell diagram versus a diagram illustrating the electric star model. Please note, for the remainder of this video, I'm reading directly from Wall's article. He states, the Hertzsprung-Russell diagram on the left is a plot of observations which must be explained by the chosen model of stars. The electrical model of stars reverses the direction of the x-axis to show the direct relationship between an increase in current density at the surface of a star and the higher temperature of that star, reflected by its change in color from red hot to white hot to blue hot. The main sequence is the backbone of the observations, but there are sharp discontinuities between the main sequence, the giant stars, and the white dwarfs. In the standard thermonuclear model of stars, the explanations for these discontinuities are beset by many observational discrepancies and ad hoc patches. In the electric star model, such discontinuities are a natural feature of a plasma discharge. Main sequence stars operate like arc lights in a cinema projector. The plasma discharge at their photospheres is in arc mode. The main sequence is a direct result of increasing the current density at the surface of a star. The white dwarfs operate more like fluorescent lights, where a fainter coronal glow mode discharge provides the light. If you can imagine the sun's bright photosphere being replaced by faint white coronal light, you have the picture. White dwarfs are not dwarfs at all. They are faint, not because they are small, but because they produce their light in a different mode of plasma discharge from stars like the sun. The current density scale for white dwarfs is different to that of the main sequence, and this is why they are scattered along a lower luminosity sequence. In the case of giant stars, the star's surface is bloated like the glow of a neon light as the star seeks to satisfy its current requirements. The red light comes from a low current density at the large diameters of the virtual anode of these stars. The stellar thermonuclear evolutionary story as it relates to a white dwarf is described in a 2008 ScienceDaily.com piece. It states, "Stars of intermediate mass, that is 1 to 8 solar masses, terminate their life as an Earth-sized white dwarf after the exhaustion of their nuclear fuel. During the transition from a nuclear burning star to the white dwarf stage, the star becomes very hot. Many such objects with surface temperatures around 100,000 Kelvin are known. Theories of stellar evolution predict that the stars can be much hotter. However, the probability of catching them in such an extremely hot state is low, because this phase is rather short-lived." An article was published on December 12th of 2008 in Astronomy and Astrophysics Letters, which claims to have discovered one of these white dwarfs, quote, "one of the hottest stars ever known with a temperature of 200,000 Kelvin at its surface." The temperature is deduced from the emission from 9-fold ionized calcium atoms thought to be in the star's photosphere. It is the highest ionization level of a chemical element ever discovered in a photospheric stellar spectrum. The stellar atmosphere modeling of a white dwarf based on thermodynamic equilibrium will give erroneous conclusions because charged particles in an electric field will be dethermalized, their random motion reduced while their kinetic energy increases. So it's easy for a white dwarf to multiply ionized calcium atoms because the electrical energy required is equivalent to a mere 211 electron volts, and not random thermal energy equal to a temperature of 200,000 to 300,000 Kelvin. Using thermal, mechanical energy is the most difficult and unlikely way of explaining the data. The white dwarf also challenges the standard stellar evolution concepts because it has a chemical surface composition rich in calcium and helium that is not predicted by stellar evolution models. A paper in the Astrophysical Journal of February 2005 shows the surprise and confusion created by this star. As usual, mechanical energy in the form of a supposed shocked wind is proposed as the origin of weak X-ray emission at 1 kilo-electron-volts. And despite the almost infinite number of, quote, knobs available to twiddle on the standard model, a match with observations has not been reached. The obstacle to an understanding of white dwarfs comes from using heat, that is mechanical energy, from within a star to explain highly energetic phenomena outside the star. It is precisely the difficulty encountered with the Sun and its phenomenally hot corona. The conceptual hurdle is exemplified by the paradigm set out in the introduction to the above paper. Quote, "The hot 106 to 107 K coronae on the Sun and other late-type stars are believed to be sustained by mechanical energy in their outer convection zones, which is dissipated at the surface through the medium of magnetic fields generated and amplified by differential rotation and convection in the interior." End quote. In other words, our present understanding of the Sun, and therefore most other stars, is based on this simple belief that to this day has not been verified. In this circumstance, it would be scientifically responsible to question that belief when new data fails to satisfy predictions. As Eddington, the theoretician who gave us the standard model of stars, wrote of white dwarfs when first discovered, quote, "Strange objects which persist in showing a type of spectrum entirely out of keeping with their luminosity may ultimately teach us more than a host which radiates according to rule. But beliefs are very difficult to shift." In July of 2008, I wrote, "A white dwarf is a star that is under low electrical stress, so that bright anode tufting is not required. The star appears extremely hot, white, and underluminous because it's equivalent to having the faint white corona discharge of the Sun reach down to the star's atmosphere. As usual, a thin plasma sheaf will be formed between the plasma of the star and the plasma of space. The electric field across the plasma sheath is capable of accelerating electrons to generate X-rays when they hit atoms in the atmosphere, and the power dissipated is capable of raising the temperature of a thin plasma layer to tens of thousands of degrees. Of course, this model will need to be reviewed in the light of new data, but at least it's a new, quite different model that easily meets the basic observational fact of high-energy phenomena outside a star. The strong magnetic fields of some white dwarfs are diagnostic of external electric currents. The spectral line broadening indicates the presence of a strong electric field in the light-emitting region. The electrical energy focused on the white dwarf is dissipated in an extensive, cool corona instead of a hot, arc-tufted photosphere. So it's significant that the spectrum of the white dwarf in the cited paper was interpreted as, quote, evidence that the X-rays originated not from deeper atmospheric layers, but from a coronal plasma encircling the star. The white dwarf, quote, became the first white dwarf thought to have a corona, albeit a cool one. The weak X-ray emission is attributed in ad hoc fashion to a, quote, shocked wind. This is like a dentist using a jet engine to X-ray your teeth. The presence of anomalies in the star's spectrum, both in the elements present and their state of ionization, is more accurately explained by the electrical model of stars, which have a cool core of heavy elements. The authors note, quote, a coronal model requires a total luminosity more than 2 orders of magnitude larger than that of the star itself, unquote. An electric white dwarf emits light from both the corona and the thin, brighter plasma sheath that forms its photosphere. An electric white dwarf is a far simpler model than the, quote, collapsed degenerate stellar corpse model. The star is not dying. It is not evolved from another type of star. It is not an impossible object, a sun squeezed to twice the diameter of the Earth. Stars cannot suffer gravitational collapse to a theoretical form of, quote, degenerate matter that has never been observed, where atoms are squeezed together so strongly that only electrons in adjacent atoms prevent further collapse because they cannot share orbits. Just how far-fetched this notion is can be gauged if we consider that the electric repulsive force exceeds the gravitational force by 39 orders of magnitude. Subrahmanyan Chandrasekhar was awarded the Nobel Prize in 1983 for his theoretical work on electron-degenerate white dwarfs, which predicted the existence of a relationship between mass and radius for a degenerate white dwarf. This theoretical mass-radius relation is a generally accepted underlying assumption in nearly all studies of white dwarf properties. In turn, these studies, including the white dwarf mass distribution and luminosity function, are foundations for such varied fields as stellar evolution and galactic formation. The notion of stellar collapse led on to more extreme theoretical fictions, neutron stars, and black holes. The damage wrought by such an assumption for our understanding of stars and the cosmos cannot be overstated. A recent paper in the Astrophysical Journal warned, quote, one might assume that a theory as basic as stellar degeneracy rests on solid observational grounds, yet this is not the case. Comparison between observation and theory has shown disturbing discrepancies, unquote. The paper cited here adds to the discrepancies. In summary, nearby red and white stars that appear faint are not different to other stars. Red dwarfs are physically much smaller than the Sun, but their visible glow discharge is large and of low current density and energy. White dwarfs, on the other hand, are physically larger than red dwarfs, but generally smaller than the Sun. Lacking bright anode tufting, they have an extended coronal-type discharge and photosphere that emits faint whitish light, ultraviolet light, and mild X-rays. The spectral lines are broadened, sometimes to the point of disappearance due to the coronal electric field. This gives the misleading impression that hydrogen, whose spectral lines are smeared the most, is missing in many of these stars, and that therefore they are remnants of larger stars that have lost or burned their hydrogen fuel. Significantly, the larger the white dwarf, the lower the current density, and the lower the apparent temperature. This trend has been noted with some puzzlement by researchers. White dwarfs the size of the Sun and a little larger are stars under lower electrical stress than normal. This may occur, for example, in binary star systems like that of Sirius, where one star usurps most of the available electrical energy. There are no collapsed stars of extraordinary high density. The story of stellar evolution is fiction. The numbers of small red and white stars exceed the number of bright stars. They are formed in the same Z-pinch mechanism in dusty plasma as are all stars. Or they may be born later by parturition, or nova, of an unstable, larger star. The economy and success of the electric universe model is readily apparent.